All right, so next up we'll talk about constitutional isomers. So constitutional isomers are compounds that have the same molecular formula, but different bonding arrangement. And so the properties of a molecule not only come up from what elements are involved, right, what it's made of, but how those elements are arranged, right? So let's take a look at an example of that. So for example, we could have C2 H6O, right? And we can think about the ways we arrange these. Again, the hydrogens are always terminal, so kind of ignore them for the N, right? We could put this carbon that's going to have 4 bonds next to another carbon that's going to have 4 bonds, next to an oxygen, which is going to have 2 bonds and 2 lone pairs. And then we could add in the hydrogens. And then just double check that your hydrogens are correct, right? We have 6 hydrogens in the formula, and we do indeed have 6 hydrogens in the structure. If you have less in your formula, then you might have to add a double bond or a ring or something like that. And so this compound right here is what's known as ethanol. And it has a boiling point of around 79 degrees Celsius. And then if you drink ethanol, you're going to get drunk, right? This is alcohol, the alcohol that you drink. But let's think about another way we could arrange this, right? In this case, we put the first 2 carbons first and then the oxygen. But we could go carbon, oxygen, carbon, and then fill in with the hydrogens and double check that we have the right amount of hydrogens. In this case, we do. We have 6 hydrogens, just like our molecular formula tells us. And in this case, this compound is known as dimethyl ether. And it has a boiling point of approximately negative 23 degrees Celsius. And if you drink dimethyl ether, you're going to die. I guess if you drink enough ethanol, you're also going to die, but definitely a lot less dimethyl ether needed to kill you. And so, as you can see, just because they have the same molecular formula, they're completely different compounds, right? And their condensed formula would be different, right? This would be CH3, CH2, OH, and this bottom one would be CH3O, CH3. So these molecular formulas, when you just list it like this and group everything together, when it comes to organic chemistry, they're not that useful because even for this small molecule, it could be 2 different options. Once we add more and more elements, it can be a whole bunch of different things. So we need to be a little bit more specific. And thinking about how many different constitutional isomers you have for any molecular formula is good exercise because it can help teach you that or help you understand these rules that we learned. So let's take a look at another example. C3H7Cl. And so remember, both hydrogen and chlorine have to be terminal. And so we'll start off with just our carbons. All right, carbon with 4 bonds connected to 2 other carbons. And then we can think about where we want to put the Cl. Well, we could put the Cl right here on the first carbon. And then fill in our hydrogens, make sure that our Lewis structure matches our formula. In this case, it does, right? We have 7 hydrogens in each, so we're good to go there, right? So we chose to put the chlorine there first. That's one constitutional isomer of this molecular formula. Let's take a look at another one. Again, since we only have these 3 carbons, since the hydrogen and the chlorines are terminal, we can't really mess around with those too much. And so we put the chlorine on the first carbon. Here we could put it on the second carbon. And then these 2 would be different compounds, right? This top one would be what's known as 1-methyl or 1-chloropropane. This bottom one would be 2-chloropropane. But remember that single bonds can rotate. And so, for example, if you drew this structure over here, these 2 compounds would actually be the same thing. They're the same exact element. All you did was rotate this bond, right? And so that's not a different compound, right? If you take your hand and you rotate a little bit, it's still your hand. And so these would not be two different constitutional isomers. There's only two different constitutional isomers you can draw here. And again, another thing to be careful of is you might be thinking, oh, well, I could put the chlorine on the third carbon. Well, if you think about these two, they're also going to be the same exact molecule. All you did was flip it here, right? So drawing these constitutional isomers can give you good practice of visualizing these molecules and learning these simple rules that we've learned. So definitely do some practice problems.